Hello. Okay, so we're here to figure out how to do the problems in the worksheet that I left you guys. And the worksheet that I left you guys, called Stoichiometry Problems, is nothing, there's really nothing new in there. It's just a different strategy. You have to kind of think on your feet and figure out, okay, so how am I going to go ahead and solve these problems? And you got to figure out, okay, well, what quantity do I need to find? What quantity am I given? How do I get between those two things? So what I have here is I have this kind of this little kind of graphic here that shows how we got from certain quantities. Like, if you did a mass problem, what you were given is you were given grams of a substance. We'll call substance A the given quantity. Could have been a reactant, could have been a product in your mass problems. As long as you're given grams of something, that was your grams of your substance, right? And so in a mass problem, you were given grams of one substance. You were asked for grams of another. We'll call that substance B, right? And the question is, how do you get from grams of A to grams of B? Well, you would go ahead and take the grams of A, turn it into moles of A, right? And once again, A is the substance you were given. Could have been any substance. And then once you had moles of A, you can use the coefficients right here, coefficients in your equations. You can use that and turn your moles of A into moles of B. That's where we got the coefficients. That's the one thing we learned in chapter 12, right? The one thing we've really learned in chapter 12. Then once you have moles of B, you can turn them into grams of B. And these are basically the steps that you were um, you were given right now, right? I mean, that you went through to solve a mass problem. Okay, so really it follows kind of this chart here where you start with grams of A, turned it into moles of A, then moles of A got turned into moles of B, and moles of B got turned into grams of B. Remember, I'm using A and B because it'd be any substance could be A, any substance could be B. It just depends on what you were given and what you're looking for, right? Now, this worksheet's going to have a little different problem. It's going to have a problem that looks more like this. Uh, Here it says, given the following chemical reaction, SiO2 plus 4HF go to form SiF4 plus 2H2O. And the question says, how many molecules of HF are required? See here, it's asking for molecules, are required to form 13.6 grams of SiF4, right? And so in this one, you're given grams, right? You're given 13.6 grams. That's the number you're given. Let me go ahead and get rid of all the writing that I put up here. All right, it's coming. All right, so this time you're not given grams. You're given grams. What's different is that you want to find out how many molecules you can end up with. So you are given grams. So you are given this quantity right here. Right, I guess I can circle this here. You're given grams of your first substance, grams of A, and you're asked to find molecules of B. Oh no, how am I gonna do that? I was given grams. He's asking for molecules. I'm confused. Okay. Notice that all these things are related, and we've learned all of them. We've learned how to turn grams of a substance into moles of a substance. We've learned how to turn molecules of a substance. See right here, into moles, right? What we do, we divide by Avogadro's number, right? This is why we learned this a month ago, so we can use it now. And you can go back and forth. You can turn moles of a substance into molecules by multiplying by Avogadro's number. So there's all kinds of stuff that can be done. So in this case, there's actually more than one way to do this, but I think it's easiest to do it when you're not using scientific notation so much. So therefore, the easiest way to do it is to uh, get to molecules through other numbers, through moles, because moles tend to be smaller numbers, molecules tend to be bigger numbers, right? So you go start off by being given grams of A. Then you can, from there, you can turn it into moles of A, right? You just divide by the molar mass. Turns it into moles of A. Then once you have moles of A, you can turn into moles of B. So this is looking a lot like the mass problem I just gave, right? The thing is here at the end, instead of turning moles of B into grams of B, You turn moles of B into molecules of B. You go this direction. You multiply by Avogadro's number, and that gets you your answer. Right? So see, all these things are related. We've talked about them before. You know how to turn moles into molecules as well as moles into grams. So these problems are just going to kind of, if you're given grams, you're not going to be necessarily be asked for grams. You're going to have to, um, you know, find out what do you need. What am I looking for? And basically, it could be molecules. It could just be moles, right? And so therefore, you just stop after the second step. You have to go through all of them. So you have to be a little bit more versatile and read the question and go, all right, what am I given? What am I looking for? And where would that be on this chart? Right? And how do I get from my beginning spot to my end spot? Okay. Nothing on this worksheet is new. All right. It's just, not so as step by step, and it requires you to think a little bit as to what we're going to get. But you know how to make all these conversions. The other way you could have done it on this one is to go ahead and turn grams to moles, like we did, then turn moles to molecules, moles of A into molecules of A. And then once you have molecules of A, turn those into molecules of B. So the second way to get there. But once again, you're going to get a scientific notation number for moles of A, and then get into another scientific notation number for moles. From when we turn into molecules of B, right? And you know, um, you know how to do these. You've done all these problems on all the worksheets. If you've done the worksheets. So let me go ahead and show you um, how to do that problem by actually doing the calculations. Right? So really what we're doing here is starting off with grams of A, then I'm going to turn it into moles of A. Then once I have the moles of A, turn it into moles of B using the coefficients. Then once I have the moles of B, turn it into molecules of B. Right. So in this case, A is SiF4. It's what I was given. And B is HF. Right? So here's my A, and here's my B. All right, so let's go ahead and do this problem right here. One thing that I'm going to do right now, in the interest of time, so that while we're doing the calculation, I don't have to stop, is I'm going to calculate the molar mass for SiF4 and HF so that we can then go ahead and calculate it. So HF's molar mass is going to be hydrogen's 1.01 on the periodic table, 0.01. Fluorine is 19.0. So basically 20.01 grams per mole. Right? And SiF4 is going to have a molar mass of, see, Si is 28.09 on the periodic table, plus every fluorine is 19, so there's 4 of them. 4 times 19, it's going to give me 104.09. 104.09. Oh, wait. I'm not going to need both of those. I'm just going to need the SiF4 one, right? Because I'm going to molecules with HF. All right, so let's go ahead and do this. All right, so don't want to kind of cut that out, but I'll move it as I need it. All right, so write down my given. I was given one number, 13.6 grams of SiF4. Right. Then I'm going to convert that into moles. SiF4's molar mass, I just calculated out, is 104.09 grams per mole. Okay, so 13.6 divided by 104.09 is going to be 0.10, 0.13. I'll write it down. 0.13. Let me try a better point. 0.1307 moles of SiF4. Okay, so there's 0.137 moles of SiF4 is my first intermediate calculation. Okay. I can go ahead and take that and then turn that into moles of HF. Okay, so I got 0.1307 moles of SiF4. Right. Really, all I did was take this, brought it down to here, right? And then, according to the, if I want to turn it into my moles of my second substance, I want this to cancel out, right? This is my mole conversions. Right, so I want my moles of SiF4 to turn into moles of, what is it? HF. See, the key is to turning stuff into moles. Moles is like the central quantity. You turn moles stuff from moles of one thing, moles of the other. Then you can turn into moles and can turn to molecules. You can turn to grams. And the coefficients for HF here, so I can put in there, and in the equation is a 4, right? And for SiF4 is a 1. There is no coefficient there, so it's a 1. So I'm going to put a 4 here. I'm going to put a 1 here. Basically, what it's telling me is 0.1307. 0.1307 multiplied by 4 divided by 1. And that's going to give me my number, 0.1307 multiplied by 4 divided by 1. It's going to give me 0.5228. 0.5228 moles of HF. Okay, so now I have moles. If this was a mass problem, I would just turn the moles into grams by multiplying by the molar mass that I'd calculated here for HF, which now I don't need because this question is not asking for grams. It's asking for molecules. Right? So in this case, what I want to do is just turn those into molecules. So I take my 0.5228 moles of HF. I'm going to turn it into molecules, right? Right. In essence, you can see what I'm doing here. I'm just taking that number, bringing it down here. And then in order to turn it into molecules, what do you multiply by? The same number as always, 6.02 times 10 to the 23rd molecules per mole for every 1 mole. And that's going to give us an answer. I'm going to write down here because it's a big number. 0.5228 times 6.02 times 10 to the 23rd is equal to 3.15 times 10 to the 23rd. 3.15 times 10 to the 23rd. And that's molecules of HF. Okay, and there is your answer. Okay, that's the full answer to this question. They're asking for how many molecules. Right? So, how many molecules? And that's how you would solve those, right? So, yep, we start off with 13.6 grams here. Let me do a different color. All right, so 13.6 grams. That turned into, how many moles was that? Going back over here, 0.1307. 0.1307 moles. And these were of SiF4. This is SiF4. And then we turned it into moles of HF. And that was, what did I have there? 0.5228. 0.5228 moles of HF. That didn't get turned to grams, although I could have. But we got our number of molecules, 3.15 times 10 to the 23rd. All right, 3.15 times 10 to the 23rd molecules of HF. And there you go. Okay. So that's how you can do it, these problems. Okay. One last thing is, don't forget, way back from the beginning of the year, we learned the relationship between grams and liters or milliliters was volume. So there will probably be some questions where you might be given volume. You might be given, let's say, liters or milliliters. So liters or milliliters, that's volume, right? And you might be able to give that, and you can turn that into grams. Remember that density is equal to mass over volume. So if you were given, let's say, a volume, um, then you can go ahead and solve for uh, mass, right? Mass is equal to density times volume, right? So if you were given that you had 35 milliliters of something, and the density is 0.735 grams per milliliter, you just multiply those two numbers together, and that'll get you your grams. Okay, so you can even extend this whole thing that we have here, this whole chart that we have here, so that you can go ahead and turn milliliters into grams, which can be turned to moles, which can be turned moles of another substance, which can be also turned back into molecules or grams. And if it's turned to grams, you can also then turn it into milliliters or liters, right? As long as you have the density. Okay, so that's how you do this worksheet. It requires no new knowledge. It just requires some practice trying to think of the relationships and how you get from one place to the next. Okay, so good luck with it. Anybody's got any questions later on, I will go ahead and answer them later on.